Welcome to the AI Show, Auckland's monthly AI event. This month, we hosted a special event showcasing Kiwi companies building world-class tech with computer vision. Peter kicks off the event with an overview of computer vision and various applications.
Okay, so I'm Peter. I've been in technology and AI for far too long, but computer vision in particular, probably over 20 years. And a whole lot of cool stuff's happened during that period for me, and I've seen it, and I've kind of gone along with it. So at the moment, everyone's looking at generative AI, but I'd like to remind people of where we got to with computer vision, which is really powering a lot of really fundamental things and is so critically important. So it's kind of crazy for me these days, because when I started, we'd take a picture, we'd put it into a model, and behind the scenes, it looked like that. Basically, it broke it down into a set of pixels. And many of you might know this, but trust me, there will be some that don't quite get it, because then you just turn it into numbers. So the next time you put a picture through, do the numbers match? Yeah, 90%. Oh, 90%. Okay. And it's very simplistic, my approach here. But a really key thing has happened, and it's part of why generative AI has actually taken off recently. Okay. Because what I've witnessed just in my 20 years, which is actually a long time, is the picture quality keeps getting better. The models kept getting better. All of a sudden, you're working with an actual image. Okay, so there's millions of points in there. Part of that is due to the algorithms getting better, the hardware getting better, but most importantly, and the reason behind generative AI is cost. We'd train models, like simple models, just looking for one thing. It could be a cat, and would have 500 images and it would cost $500. Today, it's just done. It's pennies, not even anything. And that's why you're getting things like this. Okay? Everyone's been working on this for years, but this is obviously an X-ray of a human chest. And, little things, little details like this, that's what it can pick up on now, because thousands of people have been training it, evolving it, but the picture quality got better. Okay, the cost to run this for a hospital got affordable, so it runs at scale. It's not replacing radiologists, but it might pick something up that they hadn't thought about. It might pick something up that they missed. Okay, people aren't perfect, nor is computer vision to a degree. Sometimes it can get wrong, but there are a few reasons why it gets it wrong. Because at the end of the day, it's a relatively straightforward process. This is an infrared. You've got a photo, you label it, that's a person, that's a car, that's a person, that's a car, thousands and thousands of times. So when you run it the next time, it jumps to, I'm pretty sure that's a car, I'm pretty sure that's a person. Straightforward concept? Everyone with me? Not boring anyone yet? Okay. Hello. Apparently my lapel isn't working. So one of the funny things about computer vision, though, is you give it a whole bunch of images, and you can be very specific, but let's just generally say you have to show it a lot. Okay, so I give it these pictures of cars. It knows cars. Brilliant. Doesn't know those ones, though, because they're going the other way. It's not smart. So when you build models, you need to think of every possible situation. It could be left to right, up to down, front to back, all sorts of things, even things like skewing. So it's actually really, really time, it's a massive time draw. But there are massive data sets these days that approach this exact problem, and some of them are medical ones. And then you run into your second challenge, which is there was a group of really smart people who developed an amazing app to run on iPhones for people to do melanoma checks. Incredibly good idea, because a lot of people, they don't bother, yet it kills so many people every year. What if you could put something in someone's hands and it goes, yeah, you're gonna probably want to go and check that out, then they will. So solving a real problem, providing real value. Okay, so they did it. They trained it on millions of points of data, built this incredible model, built it into the app, took a photo, didn't bloody work, did it? Can anyone guess why, just based on those two pictures, except for him? Anyone? What?
The edge is not smooth, so folks struggle to pick up what is it.
Maybe.
Training data is just so different to the actual data with verification. The algorithm
No, there was no ruler in the pictures. And every picture they had, there wasn't a ruler like that. That was the best I could find. But you know the ones that are like this and they put it next to it? They hadn't taken that into account. So they trained it on millions of things and it was perfect. Okay? And that's where the real value of people working in the space comes in, because you're talking about creative problem solving. The next two speakers, that's what they do. The technology is, yes, very amazing and it has broad application and it can provide a lot of value to solve real problems. In fact, I had one myself. Those are my chickens. Well, at least they were a few years ago. They're passed since, but unfortunately. I wanted to know which one was laying, okay? Because I wanted to track the cost of eggs over time. I know, I'm a data geek, right? But that's what I wanted to do. And I can do it because I know computer vision. Took me forever to work this one out because they all kind of look the same. They're roughly the same size. How am I going to do this? And I just ended up these days, running on this tiny little camera that just lived in their chicken coop and it was solar. As it turns out, that one lays the most. The thing I also worked out is that I was trying to train it on chickens, whereas combs on a chicken are unique. Had to work that one out. Creative problem solving. So now I've got my model that looks at the comb and it goes, it's that one. That in all of the products you're going to see tonight as well, that's only the beginning of it. Because so what? It knows it's that chicken. Then what? It's all of the additional thinking. People will refer to computer vision. There's the technology, which we just covered, but then there's everything else that's layered on top. That's the intellectual property. That's the real value. That's the creative genius. That's how you get to systems like this, where it knows these are cars, but you might want to be counting them, or you might want to be counting trucks. That's an extra layer. It could be in a safety situation where you want to detect, are there too many? Has there been a crash? That kind of thing. So that's an additional thing outside of the model that stacks on top of it, and that's where the value is built. The same with tracking people. It knows what a person is, but how do you count how many people are walking one way versus the other? That's another layer on top. So that's kind of the state of play these days. And, a lot of you, well, actually, I don't know how many, but I see a lot of Teslas on the road. That's why they can do this kind of stuff. They can move through traffic. That isn't actually a Tesla driving on the sidewalk. It was just an image I found. That's where we're at today. So it's very powerful. It's real time. It can take a good picture and do a lot more. So a lot of people are saying, oh, what's cool? What's on the cutting edge? And it tends to be this kind of stuff. Facial recognition, sports analytics, wildlife conservation. Yeah, these are all great things. But this one, wildlife conservation, I was working on this like 14, 15 years ago, and it was pretty damn good. The stuff that really floats my boat, though, is this stuff. And it's the stuff that you don't hear about, okay? Like quantum computing optimization, because a lot of that's optically based these days. So we're at a point now where it can look at all of those circuits and help evolve them. Climate change prediction, which is a very old one, but now it's at such a scale that it can look at historic satellite imagery and start putting together far more complex models around what's happened over time. That's tremendously powerful. Exoplanet atmosphere analysis. What? And if there are any audio geeks, archaeoacoustic reconstruction is a thing. So they reconstruct from pictures what it used to sound like in an amphitheater or in a historical building. Tough crowd. Crikey. It is very cool. So, a lot of people think, oh, it's for cars and stuff like that. And here's something that we did. This is 14 years old, and it was a prototype that ended up getting picked up by Louis Vuitton for a product launch. And they ran this in Paris. They had thousands of these things everywhere. Really cool, really simple little idea. So to train the model to see the light was easy. It was everything else that went on top of it. Okay, make it look and feel like you're doing graffiti. And 14 years ago, camera quality wasn't that great, as you can see. I think I had hair in that one as well. Okay, so this is where I get to the cool demo piece, except this guy, whoops, this guy trumped me. I ran a workshop last week in Wellington. He actually works for the ACC. You know, what? The ACC coming up with a cool idea? But we were running through the workshop and he was starting to put all the pieces together. And he's like, oh, hold on. So I can make my own custom GPT and it already has computer vision because it's inherently in the model. It's not going to do what you're going to hear about next, but yeah, it can read a document. It can look at a picture. And he was like, well, and this guy was in seriously amazing physical condition. You know, he was like, oh, I wish I looked like that. But he has this really complex diet. And he's like, so I can make a custom GPT, which then I can have on my phone and take a picture of a menu and it'll tell me what I can eat. I was like, yeah. And I riffed on this a bit because my wife's a celiac. So she knows what's got gluten in it, okay? A lot of people think they do, but don't. So it makes it really bloody hard for her. So I knocked this together like in 10 minutes. This is the state of play. Anyone in this room could do this. So it lives on my phone. This is the interactive demo, but I couldn't do because how do I do this on my phone? You take a picture and it says, is it safe? There it is. And this is legit. You know, if you go to that URL, you can use it. Liam Perrins, no. Okay, a lot of people, they don't know things like mirin, for example, not gluten-free. And you go, oh, but that's easy because it's Liam Perrins, right? No. It'll do it with an actual picture. It's interpretive. So it looks at the top picture and it goes, actually, that's probably a bit dicey. Here are the things that are likely safe for you. Okay? There's computer vision that you can use in your hand straight away to get a sense of where it's at these days, which is incredibly powerful. Don't rely on it for x-rays or stuff, though. Because fundamentally, technology, like anything, is best used by people who recognize one thing. A lot of people want to hear, how does the technology work? Some of you have probably heard me say this a lot, but ultimately, what is the problem you're trying to solve? That's the important thing. Thank you.